So now we're going to start section 7.3, which is going to involve more trigonometric formulas. In 7.2 we had talked about the addition and subtraction formulas for sine, cosine, and tangent. But it turns out there's a whole assortment of other formulas for the trigonometric functions as well, starting with something called the double angle formulas. The double angle formulas work for things like sine 2x or cosine 2x, where we have double the variable or the angle with our trig function. So sine of 2x is 2 sine x cosine x. The cosine 2x has three different variety of formulas to go with it. We have the cosine squared x minus sine squared x. That's one version of the double angle formula for cosine. Or it can be changed into 1 minus 2 sine squared x, or 2 cosine squared x minus 1. So depending on what we're trying to do, we can use any three of these formulas for the double angle for cosine. Now the tangent, its formula goes 2 tan x divided by 1 minus tan squared x. So altogether, these are the double angle formulas for sine, cosine, and tangent. And now let me show you an example where this particular double angle formula situation can be used to change a trigonometric expression. So here we're looking at 2 sine 6 degrees cosine 6 degrees. When we look at this thing, it looks like the double angle formula for the sine. Sine 2x was 2 sine x cosine x. So we're looking at 2 sine 6 degrees cosine 6 degrees, and so the 6 degrees would be taking the place of x inside of our double angle formula. So if we put a 6 here for the x, 6 degrees, we'll put a 6 degrees here for the 2x, and this would be equal to sine of 2 times 6 degrees, or simply sine of 12 degrees. And I'm not going to calculate sine of 12, but just to show you how we could take the longer expression and bring it down into something more simplified. Here's another example. Cosine squared of 15 theta minus sine squared of 15 theta. If we check our double angle formulas, this one looks like one of the double angle formulas for cosine. Cosine 2x, we had cosine squared x minus sine squared x. So this 15 theta would be taking the place of x in our double angle formula. So if we want to rewrite this, we can just put that 15 theta in for the cosine 2x. So this whole thing would be equal to the cosine of 2 times 15 theta, which would be the same as cosine of 30 theta. Okay, and on this example what we're going to do is something a little different, but involves the double angle formulas. It says if cosine x is equal to negative 2/3 and x is in quadrant 2, find the cosine 2x, the sine 2x, and the tangent 2x. So each one of these are going to involve the double angle formulas in some fashion. So let's take a look at how we would figure everything out. Starting with our formula for cosine. Cosine 2x, we had three varieties for it. I'm going to use 2 cosine squared x minus 1. of the 3 different versions for the double angle for cosine. And the reason why I'm choosing this one is because I know the value of the cosine x. I can actually plug that in for cosine. So this would be the same as 2 times the cosine negative 2/3 squared minus 1. And so that would be equal to 2 times positive 4 over 9 minus 1, which would be 8 over 9 minus 1, which would be equal to negative 1 over 9. So this is a situation where I could just simply plug the number in for cosine, and since it was cosine squared, just square that number and do the calculation directly. Now if I look at the sine 2x and how I'm going to calculate it, the double angle formula for the sine 2x is 2 sine x cosine x. Now in this case I can plug in for the cosine, but I'm left to wonder what the value of the sine is to plug in for the sine x. So in order to proceed here, I need to find out what the sine of x is equal to. To do that, I'm actually going to draw a right triangle. Okay, and I'm going to label the sides based off of the cosine x I have up above. Cosine being adjacent over hypotenuse. So if this is our angle here, the adjacent down here would be 2, hypotenuse would be 3. And so I can figure out what the missing side is by using 3 squared equals 2 squared plus b squared. 9 equals 4 plus b squared. And so b squared would be 5. And b would be the square root of 5. So now looking at the triangle here, we can tell that the sine of x would be opposite square root 5 divided by the hypotenuse 3. And since we're dealing with quadrant 2, we know that's positive. So now we can come over here, plug in the number for sine x and plug in the number for cosine x. For sine x, I'll put the square root 5 over 3. For cosine x, we have negative 2/3. So multiplying this all together, we would have negative 4 square root of 5 divided by 9. Now the last one is to find tangent. Tangent to x. And our double angle formula for tangent goes tan to tan x divided by 1 minus tan squared x. Now to be able to plug in and calculate, we actually need to know what the value of the tangent is. We can get that information from the same triangle we have over here. Tan x would be adjacent, or I should say opposite, square root 5 over adjacent 2. I will make this into a negative since we are dealing again with quadrant 2, and tangent is negative in quadrant 2. So this is the number I need to plug in for tangent inside of this formula. It would go 2 times negative square root 5 over 2 divided by 1 minus negative square root 5 over 2, all raised to the second power. So that would turn into negative square root 5 divided by 1 minus 5 over 4. So that would turn into negative square root 5 divided by negative 1 over 4. And dividing by the fraction means multiplied by the reciprocal, so that would be a 4 and square root of 5.